Hey, good morning students. So we discussed in last class some problems. So based on the 10th chapter mechanical properties of solids. So now today discuss some another problems. There are two wires of same material, their radius and length are both in the ratio one is to 2. If the extension produced are equal. So what is ratio of loads? Given. So now, if here given that information, so there are two wires of a same material, and the radius and length are both in the ratio 1:2. If the extension produced are equal, so what is the ratio of the loads to find out? Okay, so given that information, okay, so the radius and length both are the ratio 1:2. So the ratio length, so that is going to say L1 by L2 is equal 1/2, and R1 by R2 is equal 1/2. Okay, and if they so now given information, so the length L1 by L2 is equal, L1 is to L2 is equal 1:2, and R1 is to R2 is equal 1:2, and delta L1 is equal delta L2, and F1 by F2 is equal to find out the load. Okay, so to find out the ratio of the loads. So now, and according to the Ingomales, so Y is equal F by A, delta L by L is taken. Okay, so F by A and delta L by L. So the delta L by L is nothing but here L by delta L. So Y is equal F L by A is equal pi r square. So pi r square delta L. Okay, got it. So now cross multiplication we get, so F is equal. So to find out the F is equal F L is equal Y. So pi r square delta L by L. Okay, got it. So now in this equation, so L1 by L2 is given, R1 by R2 is given. So the delta L1, delta L2 is equal constant, same. So pi is also constant. The same gamma is also constant. So that means F1 by F2 is equal. Okay. So R1 by R2 whole square. Okay. And so L2 by L1. Okay. So F1 by F2 is equal R1 by R2. So that is equal 1/2 whole square into 2/1. L2 by L1 is 2/1. So 2 are cancelled. So F1 is to F2 is equal, so 1:2 ratio. Okay. So what is the ratio of the loads? That is called as some force applied. That is the ratio. In the ratio F1 is to F2 is equal 1:2. Okay, got it. two wires of different material, different material have same length, same length and area of cross section, area of cross section. Area of cross section. What is the ratio of? What is the ratio of? They are increasing. In length. When the forces applied. When forces applied are the same. Okay, got it. So now the two wires of a different material having the same length and area of cross section is equal. What is the ratio of the increasing in the length when forces applied are the same? And is given also. So y1 is equal 0.9 into 10 to the power of 11. So Newton meter inverse. Also y2 is also given. So 3.6 into 10 to the power of 11. So Newton meter square. Okay. Right. So now given that information, the two wires are the different material. So the different material is already we know that is called as a y1 Young modulus and y2 Young modulus. And it's the same length and the same area of cross section. And what is the ratio of the increasing length? What is the ratio of increasing the length? So here, so the same length, that means L1 is equal to L2. And also, so the area of cross section, that is means pi r square. So area of cross section, so A1 is equal, A2 is equal, A. And so the increasing the length, that is means delta L1 and so to find out the delta L2 is equal question mark. Okay, apply the force is also same. That means F1 is equal to F2 is equal to F L and that is also A. Okay, got it. So the that is the Young modulus is given. So y1 is equal to 0.9 10 to the power of 11. So y2 is equal to 3.6 10 to the power of 11. Got it. So now according to the formula, so Young modulus y is equal F by A delta L by L. Okay, got it. So now y is equal to F by A delta L by L. So now cross multiplication L delta L. And so y is equal to F, okay, F means pi r square, that is area is also taken, and L delta L. Okay, so the total extension find out. Total extension means so F in y into A into delta L is equal to F L. So delta L is equal to F L by y A. Okay, got it. So F is the same. F is means same force applied. Length is also same. Area of cross section is same. So here given. So that is means delta L1 by delta L2 is equal. So y2 by y1 is taken. Got it. y2 by y1 is taken. Okay. So y2 by y1. So y2 that value is given. So 3.6 10 to the power of 11. And so y1 value, so that is also given. So 0.9 into 10 to the power of 11. So these are to cancel. So points also cancel. So 9 4 ja 36. Okay, got it. So the y2 y1. Okay. So the delta L1 is to delta L2 is equal 4 is to 1. That is the increasing of the length or extension of the length. So the delta L1 is to delta L2 is equal 4 is to 1. Got it. So this is a very important problem. short topic. A metal wire of a length wire of a length 2.5 meters and area cross section area cross section 1.5 10 to the power of minus 6 meters square is stretched through 2 mm. Okay, if the young modulus is 1.25 into 10 to the power of 11 meters square. Find the tension in the wire. Find the tension in the wire. So the metal wire of a length 2.5 meters and area cross section 1.5. So 10 to the power of minus 6 meters square is stretched through a 2 mm, 2 millimeter. Mm means millimeter. If its young modulus is 1.25 into 10 to the power of 11 meters square, find the tension in the wire. Tension is also force. Find the force in the wire. Okay, got it. So the metal wire of a length. So length L is equal 2.5 meters is given. And area of cross section. So A is equal 1.5 into 10 to the power of minus 6. Okay, meters square. And is stretched through 2 mm stretched through. So delta L is equal 2 mm. So 2 mm is equal 2 into 10 to the power of minus 3 meters. And young modulus is also given. So y is equal 1.25 into 10 to the power of 11 meters square. Okay. Newton meter square. Okay. And so find the tension. So tension is equal force is equal question mark. And so given already we know that. So young modulus y is equal F by A delta L by L we can write. So F by A is nothing but longitudinal stress by longitudinal strain. So y is equal to F by A into L by delta L. So y is equal FL by A delta L. Okay, so cross multiplication we get so that is y is equal y A delta L is equal F into L. So F is equal to y A delta L by L. Okay, now substituting all values are in this equation. So F is equal y. Young modulus is given. So 1.25 into 10 to the power of 11. And so A is nothing but area of cross section 1.5 into 10 to the power of minus 6. And delta L. So delta L is equal. So 2 into 10 to the power of minus 3 by. Okay, L is equal, length is equal 2.5 meters. Got it. So here in this equation, so 6 plus 3, 9. So 9, so 10, 11. So 2 points. So the point is go to outside. So point here, this is the point are cancelled. So 25, so 25 5 is 125. Okay. So 15 5 is 75, 75 2 is 150. 150. Okay. So point is go to outside. So the 2 points, 2 increasing the points. 10 to the power of 4, 6 plus 3, 9. So 9 plus 2, 11. So 10 to the power of plus 11, 10 to the power of minus 11 are cancelled. So the 150 is the remaining balance. So that is called as a F is equal 150 newtons is acting on the wire. Okay, 150 newtons. So another problem, determine the pressure required to produce reduce the given volume of a water by 2%. Bulk moles of a water is 2.2 10 to the power of 9 Newton meter square. Okay, given. So P is equal B into delta V by V we can write. Okay. So now given that information, so P is means the pressure, B means bulk moles, delta V by V is means change in the volume. So determine the pressure required to reduce the given volume of a water by 2%. So reduce the given volume, so that means the delta V by V is equal to 2%. That is means 2 by 100. Okay, so bulk moles is given. So B is equal to 2.2 into 10 to the power of 9 Newton meter square. Okay, and now substituting the equation, so P is equal B 2.2 into 10 to the power of 9 into delta V by V. So 2 by 100. Okay, so the two zeros are cancelled. Okay, so the 2.2 into 2, 4.4 into 10 to the power of 7. So this is called as a pressure. Okay, pressure required to reducing of the given volume of the water by 2%. So this is called as a pressure 4.4 into 10 to the power of 7 Pascal. Okay, got it? A steel wire of a length 20 centimeters is stretched to increase its length by 0.2 centimeters. Find the lateral strain in the wire. If the Poisson ratio for a steel is 0.19. Okay. So now given that information, so the length is taken 20 centimeters. Length 20 centimeters, that is equal 2 into 10 to the power of 2 into 10 to the power of minus 1 meters. We can write. And also increasing the by length, so that means delta N is equal 0.2 centimeters. We got it. So that is also 2 into 10 to the power of minus 1 meters. 0.2. So 10 to the power of minus 3 centimeters. And find the lateral strain on the wire if the Poisson ratio is given. so the Poisson ratio is indicated by sigma. So sigma is equal 0.19. Okay, so what is the sigma? Sigma means the Poisson ratio. Poisson. Okay, so Poisson ratio or Poisson Nishpati. So sigma is equal, so lateral strain by longitudinal strain. Longitudinal strain. Okay, so lateral strain by longitudinal strain is called as a Poisson ratio. So Poisson ratio sigma is equal lateral strain by longitudinal strain. Okay, got it. So what is the lateral strain? That means Sankosinchana. Okay, so longitudinal strain already we know that. Longitudinal strain is equal Okay, so longitudinal strain is equal change in the length by virginal length. So change in the length by virginal length is taken. Okay, so change in the length is nothing but 2 into 10 to the power of minus 3. Okay, so change in the virginal length is taken 20 centimeters. That is 2 into 10 to the power of minus 1. Okay, got it. So the 2 are cancelled. So 10 to the power of minus 3. 10 to the power of plus 1. Okay, so 10 to the power of minus 2. That is equal 1 by 100. We find out it. Okay, longitudinal strain is equal. And so the Poisson ratio, lateral strain is equal. Okay, so that means to find the lateral strain is equal. Lateral strain is equal sigma into longitudinal strain. Okay, so sigma is equal 0.19 into 1 by 100. Okay, got it. So 1 by 100. So that is equal 0.0019. So this is called as a lateral strain. There is no units. Okay, got it. Right. So now today class is over, and so we discuss the next class, new chapter. Okay, so oscillations or etc. we discuss in a next chapter. Okay, thank you students.